This case study of an analysis of time to failure data to predict product life performance and improve quality is brought to you by JMC Data Experts. Controller circuit board failures were causing customer complaints for a major manufacturer of residential heating and air conditioning systems. The manufacturer had field data for their supplier's standard board and an experimental board design that would potentially improve performance. The manufacturer needed to use the data available to establish the time to failure performance of the current board and compare it to that of the experimental design. Reliability analysis is used to establish and predict product performance based on time or stress to failure data. Results can be used to determine specifications, establish warranty parameters, compare suppliers, set preventative maintenance schedules, or many other applications. Due to its mathematical complexity and specific application, reliability analysis is considered a specialty statistical analysis. There are three unique characteristics of reliability data and analysis that differentiate it from typical data analysis. First is the use of censored data. In the study shown here, 40 parts are stressed for the life of the study, with 6 parts failing at various times, and 34 parts still functioning at the end of the study. These 34 parts still functioning at time equals 20 days are called right-censored data. Maximum likelihood estimation, or MLE, is used to incorporate the information from these 34 parts into the estimate of the life performance of the population. Stress or time to failure data are not typically well modeled by the normal distribution. Therefore, other distributions such as Weibull, log-normal, exponential, and smallest extreme value are commonly used. A threshold parameter can also be added to form 3-parameter distributions when the data has been shifted up or back by some physical aspect of the data collection. In this example, the Weibull or log-normal distributions might provide a good model for the data, whereas the normal and smallest extreme value would not. The use of non-normal distributions is the second unique characteristic of reliability analysis. For our third characteristic, consider an offshore oil rig with output dependent on a miles-long drill shaft composed of hundreds of 30-foot segments. Since a tremendous expense is incurred when just one of the segments fails, the production manager is not particularly interested in the mean time to failure of these segments. Instead, the point where the first 1% fail or even a lower percentile may be of interest. Moreover, the estimate of this percentile is commonly not used for making decisions such as the timing of preventative maintenance or replacement. Because of the severe consequences of failure, a more conservative value, such as the lower bound of the confidence interval of the estimate, is commonly used. This focus on the distribution tails, and a single-sided bound of the confidence interval is the third unique characteristic of reliability analysis. Let's bring these three concepts together to determine the answers to the circuit board performance questions required by the furnace manufacturer. Distribution identification found the Weibull distribution provided a good model for the failure data. The manufacturer had to guarantee the performance of 99% of the systems, so the point at which the first 1% were expected to fail was of interest. A more conservative estimate of this value was also calculated from the lower bound of the 95% confidence interval. Based on the time to failure data, 99% of the standard circuit boards are expected to survive about 36,400 cycles. But we are 95% confident that 99% of the boards will last at least 34,000 cycles. Based on a similar analysis, 99% of experimental boards are expected to last approximately 51,000 cycles, which was a 40% improvement over the standard board design. Even though the embossed design was more expensive, the manufacturer was able to justify the increased cost by the anticipated improvement in board life and decrease in system failures. In the end, they improved the quality of their systems by switching to the new board design. If reliability analysis would allow you to better understand and predict the performance of your parts and systems, or if you have any questions about this case study, contact us at JMC Data Experts.